This is the introduction to the AP reactions problems that are finding their way onto the AP test for chemistry. So here's some general tips on tackling these problems. They have gotten easier over the years. The ones in the 80s and 90s used to be pretty brutal, but nowadays in the knots and the tens, they're pretty easy. Um, some general tips are: if nothing seems to be occurring, you should assume it's a coordination complex. If there doesn't seem to be any oxidation or reduction, if there doesn't seem to be any replacement occurring, just assume coordination complex. That's your best bet. If something is heated in the presence of oxygen, it almost always is a combustion reaction, but it may not be, as a later example will shows. If two salts are in solution, you want to first look for precipitate. You should definitely memorize your solubility rules. These are extremely important for the AP test because they may show up in not just the reaction section, but also the multiple choice, and they may even show up on other free response questions in your calculations, which could be disastrous if you can't even find the first reaction, and the rest of the parts of that problem depend on that reaction. So, and obviously, if there's no precipitate, just assume there's a coordination complex like you would always do. Okay, so now let's get to the problems. A piece of solid strontium carbonate is dipped into a 0.1 molar solution of hydrochloric acid. Okay, so strontium carbonate. The strontium ion is 2 plus, right? So we have strontium and carbonate. 1-to-1 ratio because the strontium ion is 2 plus and the carbonate ion is 2 minus. So, and then we have hydrochloric acid, a solution of hydrochloric acid, so we have H plus ions and Cl minus ions. So how is this going to react? Well, we know that carbonate acts as a base in solution. You should know that. That's a good fact to know. Because the coordination complex, let's draw that out, of this carbon is very unstable. So we have a double bond, a single bond. It's bonded to carbonate. So it's carbonate, so it's bonded to 3 oxygens. So this is a coordination complex, and the double bond can switch. We should really draw these lone pairs. So the double bond can switch between any of these 3, so it's a very unstable compound. So that's why oxygen is very easily ripped off of it by our H plus ion. So let's draw that out. So we have SrCO3, strontium carbonate, plus our hydrogen ion goes to our CO2, because that's what we get when it's ripped off, plus our H2O, plus what is left, which is our Sr2 plus. Okay, so now what would be observed as the reaction occurs? Okay, so this is going from a solid to a gas. So we have gas bubbles. That's one thing. You could also say it dissolves in the presence of acid. Okay, and this one's even easier, but this is a counterexample to what I said when I said that when you heat something in the presence of oxygen gas, it's usually combustion. In this case, it's not combustion. It's actually going to be an oxidation reduction, which is not combustion. So we have magnesium metal plus oxygen gas goes to magnesium oxide, right? Because we're heating it so that we can break down the bonds on the oxygen gas, and cause it to bond with our magnesium. So now we just need some basic facts about oxidation numbers and how we assign them to answer part 2. So magnesium is a metal in its standard state, so its oxidation number is 0. And then oxygen, and then magnesium in its magnesium oxide is, since oxide is 2 minus, it's always 2 minus unless it's a peroxide, in which case it's 1 minus. Then, so we know that since this is not an ion, we know that the magnesium is 2 plus. So 0 to 2 plus. And there we go.